Alright, it is recording, yes. Alright, for the top here, we have some derivatives, couple things that we've talked about already, and a couple new ones. It says let f and g denote differentiable functions. C, m, and b are real numbers, so they're just constants, and n is a rational number. Alright, just means it has to be written, it can be written as a ratio. So it could be a fraction, could be a whole number, integer, for this exponent for this one. First, remember our notation, the d over dx out in front of something means take the derivative of. So if we take the derivative of a constant, what do we get? 0 is correct. For our next one, derivative of a linear function, mx plus b, that's just like y equals mx plus b. Derivative of a line is m, the slope, right? Because it has a constant slope, so every point is going to have the same derivative. Next one, the derivative of x to the nth. Remember, this is the one where it could be a rational function, or not a function, but a rational number. Power rule, what do we get here? N times x to the n minus 1, right? We subtract 1 from the exponent. How about if we have a constant in front of a function? What's that, Mario? Not 0. What if that constant wasn't there? We would just write the derivative of f of x, right? The constant just gets multiplied by the derivative. Basically, the constant just kind of stays out in front. So we have c times the derivative of f of x. So we dealt with that before. Like an example would be if we had 2x to the third, the derivative of that 2 stays out in front, we bring the 3 out to multiply by it. So our derivative would be 6x squared. Right? So if this is y, then the derivative of y would be 6x squared. That rule works for other types of functions too. If we have a constant in front, it stays there, and we just take the multiply it by the derivative of the rest of it. All right, these next two are like the ones, or these are the new ones. The other ones we've kind of dealt with before. If we take the derivative of f of x plus g of x, so the sum of two different functions, what do you think it's going to be? The derivative of f of x plus the derivative of g of x. All right, it's pretty simple. We just take the derivative of each and then add those. Kind of like limits. It has the same property of limits. Remember, derivative really is a limit. We can take the limit of one plus the limit of the other. Same with derivatives. Same with subtraction. So here we'd have the derivative of f of x minus the derivative of g of x. Whoops. Minus the derivative of g of x. All right. So, since we took the quiz today, we're not going to go through the proving part. All right, that's just with the limit definition. I know you guys are going to be really sad not to do that. But let's take a look at some examples down here using those two new properties we just talked about. For the first one, we're just taking basically the derivative of each part, right? We have 4 terms here. So take the derivative of each. What's the derivative of 9? 0. What's the derivative of x? 1. It's like 1x. That's linear, so we would just get 1. Right? Or think of it as x to the first. Bring the 1 down in front. Subtract 1. We have x to the 0, which is just 1. Plus 6x. And what about the last one? Minus 12x squared. All right, number 2, you had something kind of like this in your quiz, or at least part of it. First, let's write this. How do you write that, George? What? negative 4x to the 1/3. Right, if it's a cube root, we write the 3 in the denominator. We have a fraction for the exponent. Minus 2x. How about if we have an exponent under there? That goes to the top, so we get 3/4. So it helps us to kind of look at the derivative, or look at the original function like this before we take the derivative. But the same thing, 1/3, bring it out in front. We get negative 4/3 times x. Subtract 1 from the exponent, we get negative 2/3. For this one, multiply 2 times 3/4, we get 6/4, but that simplifies to 3/2. Times x, subtract 1 from the exponent, we get negative 1/4. Alright, go ahead and try 3 and 4 on your own, please. Try 3 and 4.
Feels good. Not big, whatever it's called. Oh, yeah. I think I did number 3. He is proud of me.
Nighthawk, you're up.
Okay, that off. Go Nighthawk. Let's go. Oh, wrong. Sorry. Alright.
That's a negative 2/5 if you can't read that.
Yeah, Maz. I called Tyler ugly.
Can you fix that, like the negative 6, so we can read it? Is that a negative 6? No, in the middle. No, it's negative. It just doesn't look like it's negative 6. All right, close enough. Or just erase it. George, you got 4. Actually, I checked it. George asked me to check his like 2 minutes ago.
What? Say your hawk.
Yes.
I can't wait to see what it looks like at something every day. Oh my god.
All right. Looks good. Thank you. All right. So, with addition and subtraction, pretty simple, basically the same stuff we were doing before. Next part asks the derivative, or it says the derivative of a sum is equal to the sum of the derivatives. That's what we just talked about. Right? Same with the difference. question is the same true for products of derivatives? Does the derivative of f of x times g of x equal the derivative of f of x times the derivative of g of x? Let's take a look and see if it works that way. So on the left here, if we go ahead and look at 3x squared times 5x to the fourth, how can we simplify the inside of that before we do the derivative? 15x to the sixth. What's the derivative of 15x to the sixth? 90x to the fifth. Multiply 15 times 6, subtract 1 from the exponent. Let's see, is it equal to the other side? So derivative of 3x squared would be 6x. Derivative of 5x to the fourth, 20x cubed. If we multiply those, we get 120x to the fourth. So that does not work. Right? It's not as simple as like the adding and subtracting derivatives. For this, the product rule, it's a little bit different. When we multiply two functions and then we're taking the derivative of that, it looks like this. We're going to have the derivative of the first function times the regular second function plus the first function times the derivative of the second function. Those of you in honors learned this last year. I don't think regular pre-calc learned it. Okay? Okay, so this is definitely something you want to put on your chapter review guide. Okay? Something you need to know. So if we look at the first example here, we have two functions. So this is going to be like our f of x, the 2x cubed minus 5. This is going to be like our g of x, the x squared minus 4x. So if we want to take the derivative first, we're going to take the derivative of f of x. Oh, let's just write it out here. Times g of x plus f of x times the derivative of g of x. So what's the derivative of f of x? 6x squared, and then we have the 5. What's the derivative of 5? 0, right, because it's a constant. So there's the derivative of f of x times g of x, so that stays the same, x squared minus 4x, plus f of x, so this stays the same, 2x cubed minus 5, times the derivative of g of x. So derivative of this, take it one piece at a time. Derivative of x squared, 2x. Derivative of negative 4x, negative 4. All right, then we want to just have this simplified, so the rest is just algebra. We can distribute and combine like terms. So we have 6x to the fourth minus 24x cubed plus 4x to the fourth minus 8x cubed minus 10x plus 20. If we combine like terms here, we get 10x to the fourth minus 32x cubed minus 10x plus 20. We could, no need to. This is fine. You don't have to factor anything out. Then I repeated it.
See, Tyler, if you would listen, maybe you would know that. What's the shortcut?
Kind of, sort of. The long process would be doing the limit of that whole thing. And technically, we could do this a little bit differently. We could multiply this out, like FOIL it, and then take the derivative. But right now, we're just using these because they're a little bit easier, things we know how to do. The real reason to have product rule is for some of the more complicated stuff we'll see later. But this at least gets you used to the format of the product rule. All right, go ahead and try number 2, please.
Yeah, Mike, you took my game. I'll kill you. Why are you laughing? Why are you over there next to the window? Oh my God. Please. Time out. I know, but like, what? Where's the f of x and g of x? Is the f of x just exponent? Just instead? Yes. Come on. I'm trying here, guys. Stop. Maybe you shouldn't be threatening to you actually can take it messed up. I like the funky rhythm. Yeah. Oh yeah?
All right, let's take a look at this one. So derivative of the first function is 2x times the second function plus the first function times the derivative of the second. So derivative of negative 3x to the fourth would be negative 12x cubed plus derivative of the next part is 12x, and then derivative of 7 is 0, so we don't have to put that in there. Then we're just distributing. Negative 6x to the fifth plus 12x cubed minus 14x minus 12x to the fifth plus 12x cubed. So if we combine like terms, we have negative 18x to the fifth plus 24x cubed minus 14x. We could factor out an x and a 2 if we wanted to, but right now, we don't need to. Alright, flip over to the other side. We're not going to do number 3 and number 4 right now, just so we can get to the other ones. But number 3, what would we have to do first for number 3 before we could take the derivative? Split it up or rewrite it, right? We're squaring this. So it's going to be 3x squared minus 5x times 3x squared minus 5x. So basically, yeah. Technically. All right. but we'll save that one for later. What we need to look at now is what happens when we divide two functions and we're taking the derivative of that. We have to use the quotient rule. So you'll see part of this is similar to what we had with the product rule. On the top, we're going to have the derivative of the first function times the bottom function, or derivative of the top times the bottom, minus, so in this case it's subtraction instead of addition, the top function times the derivative of the bottom, all over the denominator squared. So again, quotient rule, very important. We'll be using it all year. You need something to put on your review sheet. All right, for number 1, top is our f of x, bottom is our g of x. So the derivative of y, derivative of the numerator, so derivative of 3x minus 7, just 3. It's linear, right? It's just the slope. Times g of x, the denominator, 5x plus 2, minus the numerator, 3x minus 7, times the derivative of the denominator. So derivative of that, 5. So instead of putting that 5 at the end, I'm going to put it in the front of the parentheses, because that's how we're used to like distributing, all over the denominator squared. So distribute here, we have 3 times 5x, we get 15x plus 6. Remember, we're distributing a negative 5 here to both of these. So we get negative 15x plus 35. And we can just leave the denominator factored.